So hello again. I think we can start. More people join, they will join as part of the session. So thanks everyone to joining. Welcome back, or for the first time, if you are the first timer on the DevOps Meetup in Prague, at least partially in Prague. We haven't run it for a while, so we are just starting now. We will hopefully run it more regularly from now on. This is the first time we run it online, so if there are any issues, please excuse us. We'll try to sort this as fast as possible. But otherwise, it's kind of like house rules. Please keep your microphones and cameras off, so we have like a good bandwidth for the presenters. And there's going to be like Q&A after both sessions. So feel free to either pose the questions to the chat during the session, during the presentation, or you can like ask the question directly after the session. Just raise your hand and you will get space for your question. So we have two topics today. One is from Chris. He will start with GitOps done right, and then Stefan will talk about his home air quality. So with this, I'll give the screen and speaker to Chris.
Hey, thank you. Does the screen sharing work?
Yeah, it does. Yeah, thank you.
Okay, perfect. So, yeah, it's been a while since I've been to Prague, and I should have been there last year, March, but that didn't happen. So I'm really looking forward to finally being able to travel again and actually being able to come back to Prague. So the joke title for this talk is GitOps done right, but the actual title is Continuous Infrastructure First, and I'll get back later to the GitOps topic, but it's kind of a teaser. For those who don't know me, I'm Chris. I, by accident, started this small conference back in Belgium, back in Ghent, somewhere in 2009, together with Patrick. We invited 70 of our best friends, and since then, people have been trying to organize similar events all over the planet. And, well, Prague is on the list of eventually, hopefully, happening either late this year, but potentially early next year. A lot of other people know me because every time they run into a DNS problem, they curse at me because that's one of the things I've been saying for, well, close to 2 decades now. So when we talk about infrastructure and when we talk about continuous delivery of your infrastructure, a lot of people talk about this being the same as DevOps. And the first thing is obviously there's huge relationships between it, but it's not really the same. The second thing is that when people try to adopt continuous delivery, they already start with failing on the basics. And a lot of large organizations go into a transition and they say, hey, we're going to do this continuous delivery thing. It's DevOpsy. It's going to be real fun. And they fail to understand that they should start with continuous integration. And if you take the definition from Wikipedia, you'll read that continuous integration in software engineering is the practice of merging frequently, depending on where you read it, multiple times a day to a shared mainline. So trunk-based development, no branching, definitely no long-running branches. And you'll see that continuous integration is basically the foundation of eventually doing continuous delivery. And if your team is mature enough, you'll end up doing continuous deployment with those practices in mind. Sadly, what we see a lot in the industry is that people do continuous disintegration. And that's not what the CD in CI/CD stands for. But they have long-running branches. They still have merge conflicts. They still don't know how to deal with their releases. And while trying to figure out methodologies and by trying to do things like branches per release and stuff like that, they actually make things more complex than they want. So why do I want to talk about getting ops in first. And why I want to talk about it is because over the past decade and a half, I've been working with a lot of organizations, and based on my experiences with those organizations, and I'll actually discuss 3 cases a bit later. Based on those observations, I've seen what works and what doesn't work. And a lot of people already say, like, wait, what do you mean continuous delivery of your infrastructure? Like, we tolerate this for years. We've let people do manual changes to infrastructures for years for critical application. But when we talk about continuous delivery, we also say to the developers, like, you need to go through the pipeline. This needs to be automated. We don't want manual changes. We don't want... So why do we allow manual operations? It's not right. But I do understand where it comes from. It's part of the history of DevOps in a way. If you notice how we started in Europe, there were people who started from operations, who were looking at improving artifact quality, who were looking at lowering the pain, lowering the stress, and getting more stable platforms. And we were coming from a background of a lot of open source, well, mostly only open source. We had agile exposure, and we were adopting cloud practices slowly. On the other side of the world, however, there was a huge push from the developers. They wanted faster platforms to be provisioned. They wanted faster change. They wanted things to move smoother than they were used to. And in a way, those 2 goals were actually complementary and they worked together. But you see that the push comes from a different side. Part of that reason is, if you look what's happening in the States, it's startups, it's vulture capitalists, it's what are those people building? They're typically building a product to sell to a VC. They're not building something that needs to survive a long time. So they're push out code fast, push out features fast, typically lifetime 6 to 9 months. Whereas Europe, in a lot of cases, there's actual businesses, there's real customers, people paying for a service, not people trying to sell a business. And it means you need to survive. It means that your typical application is not 6 to 9 months, but 6 to 9 years, and you need to keep it up and running. And the non-functional requirements in operability is going to be much, much, much more important. So you'll see that there's always been a friction between, we're going to do continuous delivery of the application, but we're not going to care that much yet about how we do the infrastructure. We got much more YOLO ops, sadly, in certain parts of our industry. Yet a lot of large organizations are looking at, how do we transition? How do we learn those best practices? How do we learn how to deal with better software faster in our ecosystem? So let's have a look at 3 cases that I've worked through over the past, let's say 2011 till now, about that. And the first case is basically an organization. When I started working with them, it was about 80, 90 people in engineering. They had complete chaos. They were 100% Linux shop, but they had close to 0, well, 10% reproducibility of their stack, maybe. Their CI was basically a Jenkins box which was hiding under a developer's desk. Their operations teams were in constant firefighting mode. They were debugging things all the time. There was no standardization. And at some point through their journey, they were really facing that moment, which they called themselves the Apollo moment, which was, it's going to crash. If this crash happens again, we're going to be bankrupt. So they realized that they needed to change because they wouldn't survive if they didn't change. So the things we did with them first was like, hey, your CI infrastructure is not something you can trust. If that goes down, you have a problem. What about we set up one which is reproducible with multiple slaves where you have control over what's happening? And while we do that, you were already playing with Puppet back in the days. What about while we do that, we actually show your operations people how to test their code, how to have different environments and have promotions between those different environments. And then as we go, we spin up the CI infrastructure first, automated, and we start doing continuous improvements on that stack. And that was like the first 2-3 months, helping people to understand what they were doing and taking on board a couple of small applications and keep delivering updates, like really do continuous delivery of their infrastructure. And the second phase, like somewhere between the 4 and 6 month mark, was like, now we're going to really align every single component you have. One of the things they were struggling with was that they have a zillion versions of Java. They had a zillion versions of GDKs and GBoss next to each other, and there was no need for that. That was just by accident, because somebody just got the instructions to install this new application. They just developed and they just took the latest and the shiniest and never updated the other stuff. So we came up with the idea, let's make sure that we can build our environments and that we can have environments that are reproducible, that are stable, where we have standardized builds, where everything your application owner knows is going to be the same and they can switch teams. And we ended up somewhere close to the 6 month mark with a stack which was 90% reproducible, standardized builds, increased coverage from the test. And we reached a point where the Java application developers were starting to actually contribute to RSpec test for the infrastructure, because they saw that the fact that they could spin up new components in the infrastructure at a really high speed, that was really helping out. And the fact that the operations people knew how to use the tools, they learned how to use these tools, and they got the developers involved to help the operations people to learn more or how to deal with languages and testing, that actually created a bond, and it really improved the collaboration and the progress within that team. Second case I want to talk about is much larger organization, about 3,000 people in IT. And it was a really bad culture. Some developers didn't want to test. Some development teams had some CI also typically hiding under a desk. And deployments were chaotic, and the operations people were obviously nagging about artifacts, quality, and stuff that wasn't really done right, no documentation, nobody knew how things were being deployed. And then I was asked to help with the development teams mostly, see how things could be improved and start from that side. It actually took me about 18 months before, within that organization, I bumped into the first person with operation skills that, for me, was like, okay, this person really knows what he's talking about. He has the right motivation. He has sufficient experience. I mean, there were a lot of people who were claiming to do operations, but within that organization, that was application operations. That was not system operation. That was not provisioning, configuration, automation, scalability, all of those things. Monitoring was totally below par. Their automation was weird. But what mostly was around there were one-off persons who knew how things worked and who were the single point of failure. So we tried to find more of his peers. Like, we found that first person who really could make a change. And what we did, because they were the single point of contact for a lot of things, we kind of moved them out of their office so that nobody could actually walk up to them anymore and say, hey, I want this fixed. Can you fix this now? No, we moved them out of the office, created a focus team, and kind of went through the same journey we did as the team I just mentioned before. We learned them how to do infrastructure as code. We learned them how to do agile work. We actually had them build an infrastructure from scratch for their own in a pretty Scrum type of approach, because they weren't being interrupted. They were working on a steady base with a stable team. So apart from the 1 day a week they got reserved, they were not going to be interrupted. So they could plan quite well. And they were actually starting to become really successful. They started to deliver infrastructure. They started to do things. To the point where we even had like the old school AIX system administration dude who was really good in SMITing and all the other old Unix things, who completely converted to become an agile evangelist. They started to see the differences between Kanban and Scrum and figured out that Kanban potentially for an operational environment was much better for them. They started to write code for the tests for the code, and they actually started to become the coaches to help developers to achieve continuous integration and later continuous delivery. But it had taken them more than a year to really get started because they didn't include the operations people. The development processes were slow. Things didn't really improve because they had started with development. And once we saw those resources, we saw those operations people being involved, the quality started improving, collaboration started improving, and things actually started to change. Which brings me to the third case. And as you can imagine, this is the one where the operations people were totally not involved. It was once again a large transformation, similar size to the second case. And these people had decided to create a DevOps team, which was going to dictate the tools that they had never used themselves. And that team, and they actually would not never have to use them because they were not really a match for what they needed. And that team was going to basically say, hey, we're going to build this thingy. We're never having done this before. Let's do this. And obviously, the developers started to complain about the tools not being usable. Developers started to complain about the tools basically being broken. Some of those tools even enforced manual processes. Because the people that were in that DevOps team had never done CI/CD. They've never done infrastructure as code. They weren't allowed to touch the infrastructure. Within that same organization, the moment I walked in there, you noticed that people who had a DevOps role and we were sold on, hey, you can come here and do DevOps type thingies, they stayed for about 2 months and then left because they really couldn't do what they were promised. They were forced to do manual work, forced to basically troubleshoot things which weren't going to work in the first place. So it was really, by the time you met somebody who was around for a couple of weeks, you were potentially seeing him leave. They had their senior management staff leave twice. And in the end, you sat there with a couple of internal analysts, some contract-based developers, and by the end of the year, they were gone because they were out of budget. So you saw people leave late October, November, and in December, the offices were empty. They had a completely failing cloud strategy, like fill in this form twice, then submit it, we'll review it, and we'll give you a VM if we want to. Pretty much their cloud strategy. Nothing changed there as a part to having old style provisioning. They were actually adopting containers quite early, but it had set on, we're going to buy this external ecosystem from a supplier, internal supplier. You're not allowed to talk to that internal supplier. You're going to deliver this, and that's what it's going to be. So there was really no involvement at all. Basically, recipe for failure. Those three cases and many others, to me, have led to the conclusion that you need to involve those operations people as early as possible in your transition. It's going to smooth your continuous delivery adoption phases. It's going to really do things faster. And if you think about why to do this, it actually makes sense. Because if you have people who need to support things and they've never done so themselves, they won't be able to do so. It will be really hard to do so. They'll need to learn how to deal with code. And it doesn't matter which language it is. A lot of old school, and typically in a larger organization, a lot of those old school operations people have never actually dealt with code. By doing so, you manage to unblock delivery. You manage to unblock provisioning. And by doing infrastructure as code and having all this setup, you can do things like build security and metrics and monitoring built in, rather than having it as an afterthought. But still, a lot of organizations jump onto, let's buy some tool, and forget about that culture part. But to me, that culture part is really, it is the hack. If you let your teams set up CI/CD for your CI and CD infrastructure first, then you'll have those people who understand both the infrastructure and how CI/CD works, which is really going to be valuable. Obviously, there's organizations out there that think that this is continuous delivery, which is not going to work. There's organizations out there that say, well, we're not going to let our ops folks do that. But they still expect those operations people to support all of these tools. They need to support the deployment tooling, the build tooling, the artifact repository, and not all of them have that experience. And then there's obviously the people who say, we're not going to do CI. It's going to be way too expensive. We don't have tests anyhow. Budget, it's different budgets. And potentially the only reasonable argument is, this is a 2-day project. Let's fire and forget, because in 3 days we're going to decommission it. I can understand that one, but still. We also need to teach people that they need to do real infrastructure as code, not some clickety-click stuff and not fire and forget things. It has to be about code. It has to be about modeling your infrastructure, using version control, and doing things in the same way you would be doing application code, tests, pipelines, all the things. And once again there, you need to do CI. Taking that one step further, obviously, you want pipeline as code so you don't manually generate pipelines. Things like build libraries, things that are identical for everything. You can use whatever tool you want. We're still heavy fans of using Jenkins and use Groovy to use the job DSL and build things. So while we're doing this, people show up and say, yes, but we moved to the cloud. We don't need all this anymore. It's like, sure, because you don't need to spin up instances on the cloud. You don't need to spin up services. You don't need to configure security anymore. You just want to go in and click this and do this manually, because you don't need standardization. You don't need security. You don't need monitoring. I mean, it doesn't matter if you do this in the public cloud, private cloud, or your own data center. You still need all of this. Actually, today, a modern stack needs kind of 3 types of tools. You need to be able to do provisioning, where you say, hey, give me an instance. And that instance can be a VM, can be a container, can be a whole kube cluster or a whole Nomad cluster, or just some service you want to, because you want to say, hey, spin me that up. And then you want to have desired state, like either within a VM or somewhere else. You want to make sure that it always is in the state you have defined it to be, that there's no deviations of what you configured. And you want to be able to trivially see the difference between your operational environment, your production environment, and your acceptance and test environment. And you want to be sure that it is in that state. You want to have reports of those things. And then there's the orchestration part, which is for actions that aren't really typical. One-off actions, like remove things from a load balancer, decommission things, upgrade scenarios, like do this action here first and then do the other one. And often some one-off actions. So all of those things are still around. And while people are saying that the importance of automation and things is declining, that there still is a huge challenge out there. Like, how many of you can actually completely automate it, clean, spin up a full kube cluster in any ecosystem they want? And then on top of that, deploy applications, reproducible, have a pipeline, not using 30 bash scripts. I mean, as much as we try fighting and as much as we try and look at new tools, the container ecosystem today is nowhere close to the level of automation of reproducibilities that were used in VMs. Yet there's people out there, and this is where the twist comes in. Like, we've been talking about doing continuous delivery of our infrastructure for ages. And now there's this new thing called GitOps, which has absolutely nothing to do with that. But some people think it does. I'm not going to go in depth in this, but there's been other people who've done so far. If Adam Jacobs says he might be anti-GitOps, that's the thing. And even today, Steve Smith, he posted a really good blog post, which I recommend you all to read, about why GitOps is really a placebo. And I'm going to read it. It's basically what we've been doing for ages. So if you want to be hip, do things we've been doing for 10 years already, and give it a new name. Only the sad part is that most of the GitOps implementations I've seen have failed to understand continuous integration because they map a lot of their environments to different branches, which is kind of shooting yourself in the foot while you're busy. So I think my message for today is, do not underestimate the power of infrastructure as code. Do not underestimate the power of giving your operations people the knowledge and the experience to actually automate your infrastructure. Anybody has questions?
I do. So, hi. You always have great talks, and I always feel really sad when your talk ends, because you fill me with a lot of depression about the current state of things. You described it really well, but what are the things that we should be doing instead of should not be doing? Can you frame something?
Start. I mean, I hope that was clear. Like, get your operations people involved in all of the transition projects you start. And the cases I've seen, to the ones that are successful are the ones that do so. The ones that are failing are the ones who basically neglect and underestimate the importance of the operational people. The fact that no matter what kind of infrastructure you have, you need to automate, whether it's public cloud, whether it's a container ecosystem, whether it's VMs in a data center, automate them and do continuous infrastructure, do continuous delivery of your infrastructure. It's going to help you understanding how the applications need to be continuously deployed. That is basically the do. The don't, there's so many don'ts.
Cool. So I might have one question as well, while others might still think about it. There is that, I don't know if it's buzzword or movement of no ops, which is kind of going against what you're saying, right? So what's maybe your response to no ops?
No ops is something that popped up like 10 years ago. It was purely marketing. And it's kind of the YOLO ops movement. To me, it is American Silicon Valley startups where lifetime expectancy is about 6 to 9 months, who don't need to care, who don't need to worry about operations, because by the time they need to think about stability, scaling, and performance, they're going to be either bankrupt or bought by another company, and then it's someone else's problem. And that's where the no-ops movement is really shining. Another part of the no-ops movement is we are going to use completely platform as a service, and we're going to use only third-party services. Guess what? There's still ops in there. It's just not your team. It's other people doing that for you. And because you have a really tight API, which you're talking to, that's where your communication is going to the ops people. You talk to the API and it's being managed in the back. But it's still people doing things in the back. It's like the cloud. I mean, it's just other people's computer, but it's still computers. It's still machines with bits and bytes that do things. Does that answer your question?
Yeah, thank you much. So I can see a question in the chat, basically asking about if the slides are available and if the talk is recorded. So,
I don't know if it's recorded, but I'll publish the slides. Yeah, sure.
Yeah. Okay. So yeah, we can share the slides to everyone who joined the meetup. If Chris is happy with that, and if everything's working as expected, there is also recording that's going to be available afterwards. Any other questions from anyone? Cool. Yeah. Then thanks a lot, Chris. It was really interesting and really nice presentation. So thanks a lot for joining. And we can move it over to Stefan.
All right. I hope I'm sharing my screen now.
Yeah, you are.
Cool. In that case, I will start. So hello, everyone, again. I'm going to talk a little bit about home air quality monitoring. So first of all, a little bit about myself. I work at a company called Chomex. I work on the CDN. We work mostly, or our customers are mostly in Africa, and I love a lot of stuff around computers. I'm not going to delve too deeply into it. If you want to, you can check out my Twitter and you will find everything needed there. So first of all, why am I going to talk about air quality? I love cats, but I'm also allergic to cats and I have asthma. However, I still want a cat. The picture that you are seeing right now is actually from my home. I used to have a cat for around 3 weeks, like a year ago, maybe a year and a half. I wanted to get a cat in the winter because during winter I only get one allergen, and that is a cat. And I was determined to go through it and to suffer through it and to just get used to being allergic to a cat and live with it. Turns out I'm not strong enough, and I had to return the cat to the friend of mine who gave her to me. So sadly, I no longer have a cat. However, I found a really, really deep rabbit hole. So I started to think about what to do about this, right? So my asthma is triggered by my allergies. Allergies are caused by allergens like pollen, molds, cats. But what exactly is it about the cat that I'm allergic to? Is it the fur? Is it something else? Turns out it's not. It's not the fur. It's some. It's something that they create in their bodies called FEL-D1, which is a protein which gets into their skin, onto their skin and onto their fur by them licking themselves, because they have a lot of it in their mouths. But how does it get into my lungs? Well, we all shed a lot of skin. A lot of the dust all around us is actually our skin, or skin parts. And with cats, it's also obviously their fur. So can I actually measure and graph any of this? Well, turns out there's a word for it. It's called particulates, or particulate matter. As you can see in this graph, and I hopefully it's hopefully big enough so you can see it. Pollen is somewhere between 10 and 100 micrometers. Mold is between around 2 and 100 as well. There's also cat allergens, which are between 0.1 and around 2.5 micrometers. There are also viruses, but they are too small to even count with a home device. There's also some typical stuff in cities like dust or cement dust, oil smoke from cars, Smog is a huge thing. So my asthma gets triggered by a lot of stuff. You can see dust is one of them, but not a huge part, but it can be a huge part for some. Smog is a huge one during inversion. So during the winter, if there's an inversion and you can't see anything, you can be 100% sure that I can't breathe, which kind of sucks. So to better illustrate how small these things are that we try to measure, here should be a human hair, and here are PM10 pollutants, which are particulate matter that are smaller than 10 micrometers, which is mostly pollen for me and some dust. You can see that you can easily fit a lot of them inside one hair, so they are really, really small. There's also PM 2.5, which are 2.5 micrometers and smaller. And obviously it's 1/4, so you can fit 4 of them inside one PM10 item. You can also see that the fine beach sand, which is really, really small and really fine, is like orders of magnitude larger than the PM10 and PM 2.5 that we are talking about. So they are divided into categories based on their size in micrometers. Most devices that can measure particulates measure PM10 and PM 2.5 because those are the best studied things, but some devices can measure even larger and smaller particles. So we now know that we have some particulate matter, but what can we do about it? We can vacuum a lot, which helps, at least for the kind of dust that settles, but some of the dust doesn't settle and it stays in the air. We can also remove dust from all of the places in the room, which is like tables and TVs and PCs and everything else, which helps but doesn't solve any the stuff that is inside, like in the air. But we can also have some air purifiers, which you can buy. There's a lot of them, and some of them are not doing a good job. Some of them are doing a better job. But if they are marketed as allergy-related products, they usually are fine and do stuff. And if you find one with a replaceable HEPA filter, they help a lot. I bought one, and it made a huge difference for me and breathing, mostly in the summer. I have not tried it with a cat, and the issue is that when you have a cat, you tend to get her fur inside your mouth and inside your breathing, just because she is not she's too close to you for the air purifier to help. And also, not having a cat is a thing that would get rid of particulate matter, but we already decided that's not an option for me. So okay, now I know that I want an air quality sensor. So what to do? So when you Google for it, you will find lots and lots of options. Like all of these are like marketed products. This is like the most common one. It's a whole set of sensors. You can also have some that are smart. That you have a really nice graphs and all of that good jazz. You also have some that are used by people who measure it for the health ministry purposes. So what to do? So I looked at a lot of them, but most of them are either closed, and by that I mean closed source and also closed API. So you can't get the measurements out of them easily. They are usually really, really expensive and are tied to clouds and subscriptions, which sucks because I want to measure it and I don't want to. I don't want to run into the issues that people who bought the first Nest devices in America did. After a few years, the company just said they are not going to support it anymore, and then you have a really, really expensive brick at home that you can just put on some paper so they don't fly away. And most importantly, many of them are all of the above, so they're really expensive, tied to clouds, and yeah, that's not going to work for me. So turns out a lot of industries are regulated with regards to the amount of dust that they produce, and they need to closely monitor what they are outputting into the atmosphere. So they use basically industry grade things, and of course they don't want to spend a lot of money on a simple device, right? So I settled on this Honeywell item. It cost around $40, I think, with shipping and everything. It has this weird uncommon connector, but fortunately my friend had a counterpart for it and also helped me with the cable, which you're going to see in a minute. I also needed a USB to serial adapter to talk to this thing because it's an industrial thing, so it of course talks serial connection. There are also multiple different options. You also have multiple different code options that you can use. Some of them are for Arduino, some of them are for Raspberry Pis. The one that I used was based on, I wrote my code based on DevLeaks code, which I used as a base, because I have it connected to my home router, which I built from an Intel NUC or NUC. So yeah, I would like to show you how it works. So this is how it works, like 2 meters behind me. It's like this really, really cheap $2 Chinese-made, really shitty USB device, which turns USB to serial. It's connected via soldered bits, which you can see here, handmade to the sensor. So I will show you a little bit of the code. Just so you can see it. It's nothing too special. It's really easy. So I just get some Prometheus libraries. I create the sensors that I want. I set up the serial connection. And this function is basically copied from the code that I mentioned before, and basically just decodes the data that the sensor automatically sends every second. So we just basically listen on the serial line and decode all the stuff and set the counters accordingly. And yeah, that's basically it. And we are just waiting for the data on the buffer and just logging and measuring it like that. So wait a second. I should have it open somewhere around here. Yes. So let me zoom it in a little bit. You can see that there's a lot of measurements. It refreshes every 5 seconds. We can change it for last hour. You can see it, the PM 2.5, which are the more harmful particulates, are ranging between 4 and 8, which is well within the safe ranges. So just as a demonstration, I will switch this to last 15 minutes or last 5 minutes, so we have less data. And I will go and light a match right next to the sensor. So keep watching it, and you will see what happens. Okay, so it should start jumping up really soon. One of the issues is that it measures over time, so it has a window of a few seconds, maybe 20 seconds or 30 seconds, and it measures it inside there. So as you can see, I lit a match, and it jumped really, really high to around 1,000. And yeah, this is the best demonstration that you can do to see that the sensor is working fine. And by the way, levels like this, or like 500, 600, do happen in Prague, and they do happen on the New Year's Eve. So if you ever had trouble breathing during New Year's Eve, you know it's because of these particulates. Okay, let me keep this running on the next page. Well, I didn't want to do this. Let me just do this again. Let's scroll to the correct place. So yeah, you saw some numbers, but what do they actually mean, right? If you check the Wikipedia, you will see that every increase of 10 micrograms per meter cubed in PM10, the lung cancer rate rose 22%, which is kind of huge. The PM2.5, which are the smaller ones, were even more deadly, with an 18% increase in lung cancer per 5 micrograms per meter cubed. So from this, we know that even an increase of 10 or increase of 20 is bad. But what do the numbers actually look like? So I took this screenshot today, and this says that in Prague it's currently moderate. You can see that we had a top of 91 measured and the bottom of 13. In the outside, with regards to PM10, we had around 22 today, which is kind of okay. So most of the pollution in Prague actually comes from the smaller pollutants. Yeah. So should I have an alarm on these? Overall, if you stay inside, you shouldn't have that many pollutants in the air, because they just blow with the wind and they just tend to settle down. So if you're outside, you get a lot more pollution from cars driving by. Also, I am in a place where there's not that many cars around, and I have a lot of trees around, so maybe that also contributes to the air being much better than it is outside. I myself consider anything above 20 bad. I usually tend to feel something or feel my asthma getting worse at around 50. So whenever it's 50, I just know that I need to do something about the air, either run away or maybe open the windows or something like that. Usually I have 5 inside my apartment. It's around 5 in summer and 10 in winter. So yeah, I've talked about a little bit of the air quality monitoring stuff, but the rabbit hole is much, much deeper. There's a whole slew of other sensors that you can do, that you can have at home. And one of them are CO2 sensors. Those are awesome. And anything above 500 parts per million impairs thought. So currently, I think we are around 410 is the normal level outside, which is kind of high. And it's going to be interesting when we reach 500 parts per million as a normal baseline of CO2. Anyway, just to give you a little bit of like the edges that you can get normally into, when you sleep with a closed window as one person in a regular small apartment building, you usually end up with having more than 2,000 parts per million in the morning. It is also one of the reasons why it's hard to get up in the morning. So if you have the window at least open a little bit, or in some other room, so you get some fresh, clean air from the outside, you should be able to wake up much more readily. Another thing that I found out the hard way is, if you ever feel hopeless and angry in a meeting, just open a window. It usually helps a lot. And we should also have CO2 sensors in all meeting rooms, and I will try to push my company into doing it, because I think I'm a little bit more sensitive to CO2 levels in buildings and in meeting rooms. And when I go to a meeting room and it's already like full of CO2 and I can sense it, I know it's going to be a bad meeting and I will shout at people. So I don't know, we need to do something about it. There's also some open HackerRun networks of weather data and also air quality data. that you can join and actually submit your measurements. The issue is that they expect measurements from the outside because they don't really care that much about your apartment, right? But if you have a bigger network of the sensors that you have at home, you can just push them to a HackerRank network and contribute to the distributed measurements. There's also a lot of NOx, sulfur, ozone, and many other stuff that you can measure. Not many of them matter that much at home, but there are some different sensors for that. One thing that I want to mention about the CO2 sensors and why I don't have it yet is that the only ones that I found need to be rebought every few weeks, months, or years, because what they actually measure is based on some something that is that just goes away. I don't know if it's some radiation or something, but those sensors that I found, usually the cheap ones that you connect to Arduinos, those just work for a few months and then they just stop working, and you don't know that they stop working. They just give you weird data and just you don't know anything. So can I have a cat now? Sadly, no. For that, I will need a few more things that I already have planned for me. So I need a new flat with a robotic vacuum cleaner, because you need to keep all of the dust particles away all the time. The problem with my current apartment is that I have that my connecting things between my different rooms are too high, so none of the proper vacuum cleaners or automated vacuum cleaners would work here. There's also a vaccine for cats that is being trialed right now. It should be available in like 2 years, and it works by giving the cat, like forcing the cat's immune system to destroy that protein that is that we are allergic to. And so far it seems that it's really safe for the cats, so it should be fine. There's also some promising new research with mRNA vaccines, which do basically the same thing in humans. There's also selective breeding that so Siberian cats are usually the best tolerated cats, and also air purifiers. I'm mostly excited about the vaccine. You can read more about it on the link that I provided. So hopefully in a few years. And you might have noticed that we also mentioned Corona in the description on the meetup.com. So what does this have to do with Corona? When we started, or when I was at home for the first time for a few months, got nothing to do, I got super bored and was lethargic, sometimes even depressed. Nothing made sense. Nothing felt like it was worth doing. However, I still wanted the cat. And the air quality monitoring project was like a good step forward, even though it doesn't directly affect me having a cat. It was a really nice step towards that goal, and every step that I took was a huge victory. So all of the slides that I showed you before, I spent like hundreds of hours researching particulates, researching different kinds of sensors, how they work, how you can connect to them. Some of them work over USB but have proprietary protocols. Some of them work over Wi-Fi but only support 2.4 gigahertz. There's a huge smorgasbord of different things that you can use and buy. But at the end of the day, you just have to buy something that works for you and something that you will have fun with. And these pet projects are pet projects like these, and the pun wasn't intended. They all made a huge difference for me. I had multiple projects that I focused on during the quarantine, and yeah, I recommend everyone to find one with many small steps, just to feel a victory every now and then and feel like something positive is happening in your life. So that's it from me. If there are any questions, I would like to answer them right now. I see there's one in the link that there's a cat food that reduces amount of allergens they produce. Nice. I didn't know about it. I will look at that. Thank you very much. Any other questions?
So is there anything you can actively do to help the quality at home, like except like vacuum cleaning, I guess?
With regards to particulate matter, there are air purifiers, and I actually bought one. It's from a company called I don't know if I want to advertise them for free actually, but it has a HEPA filter, and it has a washable filter in front of the HEPA filter. So basically, every time I vacuum, I also vacuum the air cleaner. It also has a sensor of air quality inside, and that's one of the reasons I actually bought this thing, that I wanted to measure if when it begins to clean the air, because it only turns on when it senses that there's a lot of pollution in the air. Honestly, that there is a sensor, it does something, but the values are basically all, even if the air purifier tells me that the air quality is the worst in the world, it's still better than an average day in Ostrava. So it's like biased. But yeah, the air cleaners work very well. But if you're allergic to cats, it doesn't help that much.
Cool. Thank you very much. Are there any other questions?
So I just to motivate you, these are more recent pictures of the same cat that I returned to my friend. She's alive and well, doing just fine. So don't worry.
No animals made harm during preparation of this presentation.
Exactly.
Okay, thanks a lot, Stefan. Thanks, Chris, as well. I'm gonna share my screen just for a bit. There is a QR code with link to survey. If you don't mind, please give us some feedback. What you would like to see, how the meetups should continue, so we can like bring whatever is that you are interested in. If you have any other comments, any questions, either put it there or you can send us a message through meetups. And yeah, with that, I guess we can end it up today. Thanks a lot for everyone to joining. Hope it was interesting for you, and hope to see you next time.
Thank you, Pavel. Thank you, Chris, and thank you, Stefan.